Hey everyone. So I just wanted to explain how to do one of the problems on the homework. It asks you to use the quadratic formula. That's how you can identify it. Um, the book explains yield to maturity and how to calculate the yield to maturity on page 70, and then it applies it to the four types of credit instruments that it it introduces on page 69. So pages 70 through 74 looks like are applications, roughly 74 are applications of this. The one that we're going to want to do, or the one that's most relevant, is the application on page 73 for a coupon bond. This is an example of that. In all cases, when you're trying to calculate yield to maturity, you just write down the standard formula, which you're used to. Um, the standard formula for net present value, and then you set that equal to the price that the financial instrument is selling for. So in this case, let's write down an example here. Let's say a 2-year coupon bond. Par is going to be 1200, and we'll say that we'll make it 1100. 1,000, that's a nice round number. And we'll say that the coupon rate is 5%, and therefore the coupon payment, which is just the par value, aka the face value, times the coupon rate, is going to be $50. So when you purchase this, the net present value of all of the payments that you receive, excluding the price, is going to be 50 divided by 1 plus I plus 1,000, because that's what you receive in time 1. 1 year from now, you get $50. And then 2 years from now, you get the $1,000 par value plus a $50 coupon, but you have to discount that back to the present twice. So the first step in calculating out the yield to maturity, as you know from pages 70 through 74, roughly, is to write down the net present value for the future payments and then set that equal to the price. And it looks like, I'll just say that this is selling for $1,100. This gives you one equation with one unknown, and so to calculate the yield to maturity, you just solve for that interest rate. That interest rate is the effective rate of interest for this particular financial instrument. I'll go into this more in depth in class. But you can think of this as a bank account where you put in $1,100 and then you get these two payments out. And the question is, what interest rate would make that like a bank account? Whatever that interest rate is, that's the effective interest rate that you're getting for this financial instrument, and therefore we call that the yield to maturity of the instrument, and it's what we think of as the interest rate. So to calculate the yield to maturity, you just need to solve this, and you're probably looking at it and saying, oh, I only have to solve it. That's nice to know. So the advice that it gives is to use the quadratic equation. The quadratic equation is based on an equation of a plus bx plus cx squared equals 0, or something like that. So we need to get this to look more like that. The first step in doing that is multiplying both sides by 1 plus I squared. If you do that, then you get 50 times 1 plus I squared, times 1 plus I. We're going to multiply both sides of this equation by 1 plus I squared. Check out the math, you'll see I'm right. Plus 1,050 times nothing equals 1100 times 1 plus I squared. Now, if you distribute the 50, and then you multiply out the 1 plus I squared, and then distribute the 1100, you can collect all the terms on the left-hand side, and you will get an equation like this. And then you just apply the quadratic formula. I think that the quadratic formula that you memorize is probably ax squared plus bx plus c, so equals 0. So there's that. That's one way to do it. But I think you're probably going to want an easier way. So I'm going to suggest something different. I think when you were in school, a lot of the curriculum was designed around the technology of the time, where if you wanted to do certain analysis like this, you had to use the quadratic formula. We aren't constrained like that anymore. Now we can just have a computer solve it. There's two ways that a computer can solve it. It can either solve it analytically, i.e. symbolically, or it can solve it numerically by just kind of crunching the numbers. MATLAB solves it numerically. And then there's this product called Wolfram Mathematica that solves it algebraically. It basically does the quadratic formula for you. It's just a smart piece of software. It may seem like I'm doing a diversion, except for there's two ways that you have access to this type of computing power if you don't want to do the quadratic formula. I've shown you how you can, and you're welcome to do it that way. I encourage you to do so. It's a great review. BU gives you access to Wolfram Mathematica, but it's complicated and hard to use. So I would suggest a different product called Wolfram Alpha. You just go to Wolfram Alpha, and then you type in the equation. It's kind of embarrassingly simple. But to some degree, I mean, this is how a lot of computation will be done in the future in your generation. So you just write, say, hey, I want to solve this. I want to solve 50 divided by 1 plus I plus 1050 divided by 1 plus I squared. The little caret thing says that this should be an exponent. It should be a superscript. Obviously, I can't write that in the textbook, so we use the caret to indicate that that's squared. Equals 1100 for I. So you just say, hey, solve this for I. And then Wolfram Alpha whirs away, apparently slowly today, and it's going to go and it's going to take this equation and it's going to solve it for I. So it's important to check and make sure that it interpreted the equation correctly. It says, hey, this is what I think you wanted me to do. I am interpreting this that you want me to solve the equation 50 over 1 plus I plus 1050 over 1 plus I squared equals 1100 for I, and here's the results. It's about 1.95 for a negative 1.954. Okay, so that is the answer that Wolfram is spitting out for you. Of course, one thing you always want to do when you get an answer like this is to take a look at it and see if it makes sense. Does it make sense that the interest rate would be negative 1.95? That would be like 195% negative. It would be a pretty bad interest rate. If you recall from your quadratic equation, there's always two solutions. So as I scrolled down, I saw that indeed there are two solutions, and the other one, the more realistic one, is 0. So you're going to want to put that one down. Wolfram is kind of nice. It graphs it, and the graph kind of will help you figure that out. But one of the answers will be crazy and for the real problem, and one of them won't. Having an interest rate of 0 is a little bit crazy. That's because I just made these numbers up as I was setting up the problem. The problems that you have in the MyEcon lab will have a more sensible interest rate, like 0.02 or 0.03, something like that. And then it'll have a really weird one, like 700% or something weird, or negative. And so you can get a good answer for that for the yield to maturity. If you have any other questions, feel free to send me an email. Obviously, I made these numbers up, so you'll get different numbers. I guess the final thing that I want to say is, okay, let's just do a sanity check on this. Is this really an interest rate of 0? Well, essentially, what I said is that you get $50 1 year from now and $1,050 2 years from now. The total amount that you're given from the two coupon payments and receiving the face value, Michigan calls it par, I call it face. Both words are fine. The total amount that you're getting is $1,100, and that's the number that I made up as what you paid for it. So Wolfgram Alpha did in fact come through, and this is a sensible answer. Hope it helps. See you in class.